that's going. Okay, so anyway, so the 100, you're supposed to figure out the expected frequencies. Pretty straightforward, I hope. Determine their null and alternative hypotheses, and then compute degrees of freedom. And then I've got the table of things here, and I even give you the test statistic. So I don't know if you can see it from the back. I'm trying to make it there. That's probably there. That's kind of like the best I can do for now. But I can scroll, I can zoom in and all. But I guess the first step, though, is to get your expected frequencies. Remember, there's a total of 100 cookie recipes, and the claim is that they are all equally likely. Yeah, and you need a null and alternative. Maybe I'll just zoom in. We'll just do this as a sort of an exercise. So there it is. I'll do attendance, and then I'll scroll down. Yes? They wanted it to be bigger? What do you mean? So yeah? No, that's all right. Oh, okay. Yeah, so it, you're talking about in terms of the decision at the end. Okay, yeah. Well, let's do a quick review. This is good because normally people don't care about the homework. So thank you for caring. So here's the rule. So here's what is the decision? Decision. Okay, so bear with me. I know that you're gonna you're like, well, I just asked about this simple thing, and now you go into all this business. But anyway, so if the p-value, just to remind you, this is what you already know. When the p-value is less than alpha, you reject the null hypothesis. Okay, so that's what we know so far. That's the way that we've been doing it. And then, welcome. So then the other way of looking at this, there's two ways of doing this, and we've always focused on this way. The other way is when your test statistic is greater than the critical value, then you reject the null hypothesis. Yeah, so the second one is sort of the new way. It's really not new. It's something that has been lurking in the background all along. You know, if you have a p-value that's less than alpha, what that means is if you imagine you know, here's your test statistic, and there's your p-value. All that means is that if that's less than alpha, it means that whatever the critical value was, if we had computed it, this area is alpha here. So the p-value being less than alpha just means that you're further from the middle than the critical value. Yeah, so that's the rule, though. And it's not sometimes, it's always. Always when the critical value, sorry, when the test statistic is bigger than the critical value. So it's the opposite, which I can understand. That's why I haven't really focused on it, even though there's both ways of doing it. And it's been in the background all along. I just haven't mentioned it because it's confusing that there's two different ways, and one is less, one that's more. Well, there's no way around it with this test because we're not computing p-values. So yes, Fiala. I'm sorry. Let me write this down so that I understand what you just. Where did I? There it is. Okay. So what if you're asking? What if the critical value is bigger than the tested? Less than.
Yeah. Then, like, is it the same as that, or would it have to be like less than or equal to?
Wait, aren't these the same thing?
But I was asking, would you still reject the null hypothesis, hence making it easier to remember that they're all
Oh, yeah. These are the same thing. And so if you prefer thinking of it this way, that's a great idea. So Biela points out that if you put the critical value first, then it's always less than. I guess to me, I have the thing that I compute on the left and the thing that I'm comparing it to on the right. So you do, but whatever helps you. Mathematically, it's the same. I mean, you know that. You can switch it up if you want. So very nice. Anything else before, I mean, in this quiz, obviously I'm not collecting it because I left it on the printer. I have calculus though. But so yeah, let's go back up to the top. So thank you for helping me clear things up. So here it is. So here, I'll scroll up in just a minute. So your first job is to write a little, like make a little table and put numbers in for the expected numbers of each of these recipes. And while you're doing that, I will see if everyone is here now, which I know they aren't. Did you say you're using ChatGPT to do this?
No, no, just a long message that I was sent.
About ChatGPT?
No, it's
Okay, okay. Yeah, you do this one though. I guess you could try to see if ChatGPT could do it. Probably could.
No, I don't think it will do.
Attendance. Let's see. You're here now. Okay, that person's. Wait, that person's not here. Let's see, these two. Where are you? Well, it's her, this, here. Where are you? There you are. I think I got it all. Yeah, okay. All right, let me scroll this up a bit so that you can finish this. So yeah, null and alternative hypotheses, if you can see it, determine the degrees of freedom. Hopefully you've got everything that you need. I'm gonna scroll it. Yeah, it would have been better if I'd printed. And then you have the table. You can find your critical value, hopefully. Oh, just in case, where was alpha? 0.05. So alpha is 0.05. All right, let's see how we did. I know you probably are still doing your complete sentence, but oh yeah, it would be a good practice, even if you're like, yeah, I'm not going to turn this in, to at least have something for your complete sentence so that you have a hint as to whether or not you know what you're doing for when we get to the final. Final's coming. 3 weeks. Is that right? Next week's Holy Week. Then we have the week after Easter. And then finals week. 2.5 weeks. It's crazy. All right, let's see how you did. I'm sure you did fine up here. Maybe not. Maybe not. So you have 100 cookies. How many would you expect, or recipes? How many would you expect if these were evenly distributed? It would be 20 of each, right? Because 100 divided by 5, 20. Good. Then the null and alternative hypotheses. I didn't leave any room here, mainly because when I realized I hadn't brought the quiz with me, I condensed it to try to cram more on the screen, but it would have looked like this. So the null hypothesis is that all all cookie types, let's see, something to this effect. Cookie types are equally distributed. That's not very well written. Anything that indicates that they're all the same, so that you would say they're all 20%, that would be fine. Whatever you want to say, just that each of the cookie types is equally represented in the population. And then the alternative is that they are not. They're not equally distributed. I know in Newton, they used the phrase uniform distribution. Yeah, if you use that, that's perfect. So if you want to say like that the cookie types follow a uniform distribution, that would be the null hypothesis, and that they don't follow a uniform distribution would be the alternative. That would be fine as well. Yeah, stop me if you have a question though. Oh yeah, and then this was all 20, I guess, here. Okay, and then the degrees of freedom. So remember, we have 5 categories. Just take one away, 4 for your degrees of freedom. So 5, you don't have to write that. I'm just trying to remind you how you did it. 4 degrees of freedom for this. Critical value is going to be, let's see, we got to go find our degrees of freedom. There it is. And then alpha was 0.05. That's this. So here is the critical value. So chi-squared crit is 9.488. So here, this is super extreme. So this is really unlikely. So think of it this way, that the bigger this is, the more unlikely it is. So it's very unlikely to have a test statistic this big. That would be like, wow, you did something amazing that is, almost no chance of happening. So since 49.7 is bigger than 9.488, then you're going to reject the null hypothesis. You don't have to write this stuff. You just have to write this. Reject the null hypothesis. Did you put all of this down? Did you put H sub 0? I've been a little bit loose, and when you say reject the null, I'm okay with that. To be honest, it's better than just saying reject. If you just say reject, and I joke about the whole girlfriend-boyfriend thing, but the reason why I'm so insistent that you tell me what you're rejecting is because sometimes in the past, I've had students who think that they are rejecting the alternative hypothesis. So that's the honest reason of why I want you to tell me what you're rejecting. So tell me that you're rejecting the null hypothesis. Conclusion, there is evidence to suggest something. There is evidence to suggest. So at the very least, if you're rejecting the null hypothesis, do something like write the start of your sentence, even if you have no idea what it's suggesting. At least you've got that, and I'm like, you're sort of know what's going on, and I can give you points. It makes me happy. Like when I did your test, I was so happy. I just telling you that you guys, I think it's the best that I've had, at least in recent memory, as I'm grading my tests. I was the happiest I've ever been. But anyway, getting back to this. So there is evidence to suggest that, let's see, what is the alternative? That cookie recipes are not uniformly distributed. There you go. So that's it. All right, so yes, Hayden. I want to hear your 2 very important questions. Wait, what, huh? I don't know. I'm making things up. Okay, drop cookie. If you really want to know, take a spoon, drop it on the thing. Molded cookie. You have this like plunger and you crunch it out. Okay, how's that? Is that it? Oh, I thought it was something statistical. All right, well, thank you for that. Anything else? Not cookie related. I mean, I'm just trying to make up something that's not, I don't know. Anyway, so let's see. What are we doing here? Oh yeah, we're moving on. By the way, you're going to be using, well, I don't know if you want to or not, but I am going to be using Excel in about 15 minutes. So if you want to join me and use Excel in 15 minutes, you should have your computer booted up and ready to go, and I will even show you what to download in just a bit. For now, though, let's see, I got to grab this. Where is it? Hold on a sec. That one right there. Yeah, not that. Okay. Okay, there it is. Okay, so for now, what we're going to do is we're going to get started using some data that I kind of massaged just a little bit. I'll confess, I took the data that you gave me at the beginning of the semester, and it was similar to this, but I just made the numbers work out a little bit easier so that we won't have as much difficulty doing calculations. So back at the beginning of the semester, you told me which pet you had. Actually, some of you had multiple pets. So when I collected this data, I basically took the one that was listed first. You know, remember there was cat, dog, ferret, I forget, and then all other pets. And so I just put you into categories. So of the females, there were 2 of you who had cats, not dogs. There were 8 of you who had dogs and maybe cats as well, and maybe some other pets. Some of you had like dozens of pets, it seemed. And then there were 2 of you who had neither a cat nor a dog. Now, once again, I think that the numbers were like 1, 8, and maybe 3 here, but I just wanted to make it work out a little nicer. So if you actually go download the actual data, which is, I think, available on our Moodle page, you'll find that it's not quite like this, but this will just make the work that we're about to do easier. For the males, and this one I did have to, this one's worse in terms of my massaging of the data. But I was surprised. I was surprised when I looked at this. There were more, well, not more, there were more cat males than cat females, I should say that. So the cat males, cat females, there are more male cat people than female cat people, at least when I was looking at the data and I found, like I said, if you had a dog, you went into the dog category, all right? And then you have 4 predominantly dog dudes, and then 4 who said neither. And now the neither people, this one, I boosted that. That one, I think it was more like 2 or something. But anyway, I wanted to make things work out nicely. So what we're doing today is we're going to compare 2 variables. These are qualitative variables to ask whether or not they are related to one another. Is there a relationship between gender and the pet ownership? And so you'll notice that I have observed frequencies here. And what we're going to do is we're going to take those observed frequencies and ask the question, what if there was no relationship between gender and pet? So that is indeed the null hypothesis. So let me write this down. This is called the chi-squared test for independence. And the null hypothesis for this test is that the variables are unrelated. The variables, that's supposed to be a V-A-R-I, the variables are unrelated. And then the alternative hypothesis is that they are related. The variables are related. Now, just like when you come into the room and I greet you, hopefully by name, if I can remember your name, it's much nicer or kinder or feels more bespoke if you actually name the variables here. This is sort of a generic description of this. So instead of saying, hi, male, or hi, female, when you come in, I'll tell, if I can remember, I'll use your name. So here, this is the generic version, but it would be nice if you actually said that gender and pet are unrelated. That would be the null hypothesis. It just is a little bit more understandable, but I'm just being generic here just to show you how it works each time. And honestly, if you're doing an exam for me and you write this down on the chi-squared test for independence or on the quiz on Monday, I'm going to be thrilled because I see that you understand what's going on. Are these related? Now, by the way, when we say they are related, that's the alternative. What that means is that if you're a male or a female, your pet choice is somehow related, maybe not caused by, but related in some way to your gender. That is that females are more likely to have one kind of pet and males are more likely to have another kind of pet. So that's what it means to be related or unrelated, at least in this context. So now the hard part is here that we're going to have to come up against is to figure out the expected frequencies. So you remember on the quiz, here we got the quiz here, just a sec. So on this quiz, it was pretty straightforward, wasn't it? There were 100 cookie recipes. And if they were all equally, if it was uniformly distributed, you would say, okay, divide by 5, right? 1, 2, there it is. So you got 5 20s there. But here it's a little bit more complicated. What do we mean by unrelated? Well, here's one way to think of this, and here's why I massaged the numbers a little bit. You'll notice that there are, at least in my sample, the fake sample, which I've changed a few of the numbers, the total number of females is 12, and the total number of males is 12. So that was not the case. So this is where I was like, it's not going to be nice. And I want the numbers, at least for the first one, to come out nicely. You'll notice if you look on, well, we'll get to that. The data that we're going to use in a bit with Excel, numbers aren't as nice, but we can let Excel deal with not nice numbers. Okay, so there's the totals. Now, here's the thing. There are 6, here, I'll do another total here. There are 6 cat people. So if those two variables, if gender was unrelated to pet, how many would you expect of those 6 to be females? How many would you expect to be males? Take a guess. See if you can figure out how many you would expect in each of those categories. And I'll see if anyone wants to volunteer their answer. I knew Hayden would. Hayden, what do you think? Yeah. If there's no relationship between gender and pet, yeah, you would expect 3 and 3. Of course, because of random chance, we might have 2 and 4. That's not out of the realm of possibility. But if you have 6, you would expect it to be 3 and 3. In the same way, since there are 12 dog people in here, you would expect that to be 6 and 6. And with neither, there's 6 neither people, that's 3 and 3 as well. That's what you would expect. So we're going to have a formula for this in a minute, but let's fill this out. I've got this here, second little grid here. And so you would expect there to be 3 females and 3 males. Let's see, 6 females and males in the dog category and 3 and 3 here. Now there's a, let's see. Sorry, I just had to look and see. Yeah, I see. There's a formula, and unfortunately it's not filled out. Well, you'll see. There's a formula for this, but let's just talk through this for a minute. Where did those numbers come from? It's pretty straightforward. What you did, or at least what Hayden did, or maybe what you were thinking if you did this, is you thought, hey, there's 12 females, 12 males, that's 50-50, right? Okay, so 12, how do you know it's 50-50? Well, you can see that it's the same, but you could do this. 12 divided by 24, because the grand total is 24. So 12 divided by 24 gives you the fraction of people who are female. 12 out of 12 is 50%. And then you took that 50%, maybe you didn't realize you were doing this, but you multiplied it by this number here. So let me just show you where all these numbers are coming from. 12, and then the 24 on the bottom, you can see where that is, and then I'll just put a diamond around this. There it is. So you could do this for every one of these. For example, the dog people, the male dog people, I could say, okay, 12 out of 24 people in this room are male. Multiply that by 12. So 12 divided by 24 times 12. So we got a pretty simple formula here. In fact, here's the formula. I'll put it up right there. So this is the expected frequency. Is the row sum, okay, I guess I have this backwards from the way I just presented it, but it's still the same idea. So if I want to know what number to put, let's just give an example. Let's say I want to know the number to put right here, the male cat people. Then what I'll do is I'll do this. I'll do the cat people total times the column sum is the males over the grand total. So the reason I'm making a big deal out of this is because, well, for one, you're going to have to compute this for me on Monday, but also because we want to be able to do this with Excel. So we take the cat people, that's the total cat people, that was 6 if sorry I don't have the numbers here, but it was a total of 6, times the number of males, that was 12, 6 times 12, divided by the grand total was 24. So that's the way I'm going to be doing this when I get to Excel, and it's also a convenient way to remember how to do this in general. So you get 3 there as the male cat people. Once you have these numbers, by the way, you can do exactly the same thing that we did for today. That is to say, you add up, you do the difference. So you remember that big table? So you take, here's the observed frequencies, here's the expected frequencies, and I know it's a grid instead of a horizontal line, but you would do the same formula. So back here, I didn't make you compute this. You know, it was given to you, 49.7, but you hopefully remember how we did this with the M&Ms yesterday on Wednesday, and that is you took the 10 minus 20, negative 10, you square that, you get 100, then you divide by 20, 100 divided by 20 is 5. So you would have 5 for the bar cookies. You do the same thing for the drop cookies, so 42 minus 20 is 22, square that, 484, and then divide by 20. And then you do the same thing for the cutouts and so on, and add up all the results. Excellent. Hope things go well. Yeah, she had to take a test for me. Later in the day, she had a conflict, so that's why she was lurking back there. She's proofreading it for me. But anyway, getting back to this, that's the way you do it here. You do the same thing when you have this grid. It's just that the grid is a little bit more annoying because you have to add up, this plus this minus this divided by the expected and squared and all that. So we'll do that on Excel. So not to worry. Actually, you're gonna be surprised. It's actually quite quick. Okay, so we're almost to Excel. Okay, so here's how oh yeah, wow. That's what we're gonna do. I'll keep this on my iPad, but don't write all this down. We're actually gonna do this. So I just wanna point out what we're about to do is when you're doing your Newton homework, you're gonna copy everything to Excel. If we have time, I'll show you this with an actual Newton problem. You make a new table for the expected frequencies, which we'll do in a minute. You use this formula. We'll use this in just a minute. And because Newton wants you to, you got to round, which is stupid in my mind, but we'll do it. And then you use this. This will give you the p-value, and this will give you the test statistic, and this will give you the alpha level, or the critical value. We'll get to this. I'll put this back up here when we need it. For now, though, let's go to Excel. Let me show you what you need to download. Let's see, I've got this here. Where did I put it? Is it here? Oh, it's here. Just a minute. I'll pull it over. You can see. So if you go to our Moodle page, at the very bottom of the classwork Excel files, so classwork Excel files, go way to the bottom, you'll see chi-squared 2. Chi-squared 2 is what you want. When you open chi-squared 2, it should look like this. Hold on a minute. Pulling it over. Here, I'll put it right there so that we can still see the chi-squared 2. So here's what it'll look like when you open it. I'm zooming in really far so you can see. I'll explain what this is in just a minute. Let's see, can we see yeah, there it is. There we go. So I'll give you a minute to get yourself oriented. And if you can't find it, let me know, and we'll wait a minute and make sure that you can find it. Maybe your friend can help you. All right. So let me make this big so we can all see it. No, you got it? You got it. Excellent. Okay. Okay. So we've got our observed frequencies. And so what this is back at the beginning, this is actual data. So I didn't change any numbers because I didn't care if things didn't come out nicely, and they probably won't. We'll see in a minute because I haven't even done this one. So this was the question. Someone wanted to ask, do you wear socks when you sleep? You remember that question? Okay, well, here's the actual results. We had, of the females, 9 of the females said no, 3 of the females said maybe, and 2 of the females said yes, that they wear socks when they sleep. With the males, apparently the males are a little bit more soft than the females, because you'll notice that the males, more of them actually said, yes, I definitely wear socks because my feetsies get cold at night. So there's the data. So let's actually see how we're gonna do this. First off, I'm going to, there it is. Need to be able to see on both screens. Okay, so first off, we're going to set up our hypothesis test by writing our hypotheses. So H0 and HA, just so that we have them. You know that the deal is that the two variables are related or unrelated. So the thing that is probably the most confusing about this is that the null hypothesis is that they're unrelated. Here they are related. So it feels backwards from the way that we've been doing null, because null hypothesis is equal, right? That they are the same. But if you think about it, for two variables to be unrelated, it means that males and females are the same in terms of sock usage during sleep. So I'll just write this down, that sock usage, sleeping in socks. So sleeping in socks is, and gender are unrelated. Oh, here, I'll put this in parentheses, independent. This is why this is called the, yeah, if I could spell it, independent. I can't back because it's, anyway, I'll fix it in a minute. That's why this is called the test for independence, is because we're saying that these two things are independent of one another. They're unrelated, socks and sleep. Okay, so I'm going to hit enter. So there it is. I could fix that if I want to, I suppose. Independent. There we go. Okay, now that I've got that, let me just copy it and paste it down here and fix it. So here we say that they are related. So the alternative hypothesis is that socks and gender are related, which means that they are dependent. That's another way of saying it. I can't remember. We'll find out if we have time what Newton says, if they use related or dependent, but there it is. You've got them both. Okay, yeah, you probably can see it all. I've got it zoomed in so you can't see the whole thing. There's the whole thing if you need it. You can always pause the video later. Okay, now for the most important part, and that is how do we actually perform this hypothesis test? Well, here's what I'd suggest you do. Once you have your data in Excel, copy your data there. So I've copied it, Control C or whatever you do to copy it, and then go down here somewhere and do paste. And we're gonna call this expected. Expected. I'm also going to get rid of all of these numbers there because we're going to put new numbers down here. Now, before we do this, let's see, it's going to get annoying for just a minute. Notice that what we're going to have to do is we're going to have to compute the totals. We need the row totals and the column totals and the grand total. So let's figure that out. Let's get our row total, column totals, grand totals. So here's the totals. Whoops, if only I could type. Guess I have to sit down first. And so the total is just the sum of those numbers right above. Whoa, there it is. And I'm just going to copy that formula over. And then to get the row totals, you get the sum of the row. There we go. Now, I know that Excel does some sort of an auto sum or auto total. I forget the exact way it does it. But I found some students who use whatever that is to auto-populate this, sometimes it doesn't do it right. I don't, maybe it's an AI thing, I don't know. But anyway, you saw what I did. If you need me to, I can click on these. Those are the totals. So the sum of the row. And then this grand total, I just added up the two row totals. And then these are the column totals. So you've got those. Okay, so next I'm going to do this two ways. So that just so you know, that it's another annoying thing that I always do, but I'm going to do it the hard way and then the easy way. So notice row total times column total over grand total. That's what I need down here in the expected frequencies. So here's how this is going to shake out. I'm going to type equals. So this is the female nose. Female nose equals row total. So I click the 14 times column total. I click the 16 divided by grand total. Click the 26. and that's the expected frequency of female nose. Now you can see why I wanted to massage the numbers very slightly when we did it the first time, because 8.61 is kind of annoying. Now to get the rest of these, I'll do it. This is, like I said, this is the hard way. I would do the same thing. The maybes equals row total times column total divided by grand total. This is tedious, isn't it? We're going to have to do this 6 times. Well, there's a better way. If you want to, you can continue doing what I just did to get all 6 of these. You have to, here, I'll just highlight. These are the 6 that you're going to do. There we go, this yellow. There, you need to do all 6 of those. Where am I? Just a minute. I want some faint. Oh, well, all borders. There, now you can see. So I need all 6 of those. But here's the easy way to do it. So if you want, you can continue the way I just did. Here's the easy way, is take your first one, and you're going to use, and this is for you Excel experts out there, you're going to use relative and absolute cell references. So notice that the thing that I care about is that it's the row total. So the row totals are all in column E. So I'm going to put a little $ before the E. You'll see why in a minute. So all of the column totals, or the row totals, all the row totals are in column E. So I want to keep that column E fixed. And then the column totals are all in row 4. I know this is a little confusing, but here it is, row 4. So I want to keep each one of these is in row 4, so I want to keep the 4 there the same. The grand total, that one is always going to be cell E4. So I'll put $ before each of those. The $ just tells Excel that if you copy that formula and put it somewhere else, don't change that piece of the formula. So here, I'll show you what I mean. When I hit enter, it doesn't change that. So this is still the same. I've just put $ in there. But now when I copy and paste this, notice what's happened is it kept the E, it kept the 4, it kept these, but it changed. So if we compare that with this, F2, it changed the 2 instead of E2, now it's E3, because it's a different row. So it's just a convenient way. Now you can just copy that and paste it in. So now all of these have that. Look at this, every one of them. Oh, I just realized. Now I'm going to have to go and do it again. Yeah, what do you think, Hayden? Show the formula. Yes, here's the formula. There it is. So just as long as the $. I got to change it one more time, though. Because of Newton, sadly, I need to do this. Where's my cursor? There it is. So Newton wants you to round these numbers, which makes no sense to me. But here we are. We're dealing with Newton. So that's what you have to do to make Newton happy. And you have to do it 6 times. So if you're going to do this using the, doing it every one of them individually, you'd have to do it 6 times. But if you use the $ method, you can do it just once. Notice that that's been rounded. Now I'm just going to copy this formula throughout that there. And now it's all rounded. Yeah, Newton won't like it if you don't round. So just to warn you, got to round. Okay, so far so good. Yes. Yeah. Oh yeah, let me pause, make sure everyone's got something that looks like this. So either if you use the $, you can copy it. If you don't, you're going to have to type round 6 times. Or if you're doing this with a larger grid, it'll be 9 or 12 or whatever. I think the M&Ms, it's going to be 10 times. I'll show you in a minute. Yes, Hayden. Okay, so do you have exactly this? Every $. And then what are you doing? Are you doing this copy and then paste? Okay, you do what you, now you got it fixed? Okay, good. Anything else? So everyone's got something that looks like this. Okay, so yeah, by the way, this unfortunately is not going to be quite as nice as our our hypothesis test gold stuff, but you may want to save this so that you can refer to it later on, because there's a few things that we're going to need to do. So next, here's the order of operations. We're going to get the p-value first, and then we're going to get the test statistic, and then we'll get the critical value. I think, well, whatever, we'll just do it. Okay, so the p-value. Oh, before we do this, do we need to? On the next one, we'll need to talk about degrees of freedom. But on this one, we don't. Okay, so this is kind of interesting. And this, we could have done this, by the way, we could have done this using with the other test, the one we did on Wednesday. It would have worked just the same. So this is going to be called, it's the it's chi-square dot test. There it is. And then it says, if you can see that little hint down there, it says actual range. So for actual range, I'm going to highlight just the data, not the totals. Notice it's just the data, so B2 through D3. And then comma, now the expected range, which is the stuff that we just computed. And is that all that I need? I think that's it. Yeah, that's it. It'll figure out degrees of freedom and everything itself. Hit enter, and you should get, that's the p-value. So there's my p-value, 0.438, which is not impressive at all. This one right here? There you go. So it's, yeah, I know it's kind of hard because you can't see what I've highlighted up there, but it's basically the B2 through D3 is the observed stuff, and then this is the expected stuff. Now, by the way, I should say that you could do this the way we did the homework. That is to say, you could do the whole, computing the test statistic yourself by doing observed minus expected, square that, divide it by expected, and then do the same thing for this one and then that one and add up all 6 values. That works. That's fine. There's nothing wrong with it. It's just that this is just quicker and easier, I think. Okay, so there's that. Okay, so there's that. Okay, so we're all good with the p-value? Okay, test statistic. So this one, and this, once again, we could set this up where we just compute the test statistic using that formula, but let's not do that. Let's do it this way. We're going to do chi-square dot inv dot rt. Is that what I'm using? Just double checking my notes. Yes. Okay, so let me show you, and then I'll explain. So it's going to be that number there, and then the degrees of freedom are going to be 2 for this particular problem. I'll explain how to compute that in just a minute. But let's get this out of the way first, and then I'll explain where that 2 came from, because you might be looking at this saying, wait, there are 6 categories. Shouldn't it be 5? It's because this is a grid. I'll explain. But first of all, let's get this number. So chi-square inv root of B10 and 2, and you should have 1.65. So I'll put that there again, just in case. I'll go slowly. So I guess I should explain how to get degrees of freedom when you have a grid like this. So you know how the degrees of freedom work for like the M&Ms. You took the number of categories, subtract 1, you got 4. 5 minus 1 is 4. Here, think of this as being 2 separate groups of categories. You have the answer, you have three different answers you could have, subtract 1, you have 2. So there are 2 degrees of freedom up here. Now for gender, you have 2 genders, subtract 1, you get 1. So there's 1 degree of freedom here. The way you get the degrees of freedom for a grid here is you take the 2 degrees of freedom, the across and then down, and multiply them. So 2 times 1 is 2. So that's why it's just 2 and not something bigger. Okay, critical value, we're almost done. here, what we're going to do is, here, I'll put the notes back up here. You do the same thing with the RT, but you use the alpha level. Also, in Newton, you could just look it up in the table. But here, if you want to do it on here, it's going to be equal to chi-squa dot inv dot root. And then alpha level, I guess we're using 5% for this one. I don't know, it wasn't really specified. And then the degrees of freedom are still 2. And there it is. So if we looked it up in the table, let's see, let's see, do I have this on this quiz? I'll bet I do. Yeah, it's, so notice 5.991 is the critical value that I computed. Check it out. On the quiz, I had this table, 2 degrees of freedom, 5.991. So you could get this right from Newton as well. So you don't actually have to compute that. So now we can see, I won't write this out, but you'll see that the test statistic is less than the critical value, which means this isn't very impressive. You can actually see the p-value is huge, but there is not enough evidence to suggest that sock usage at night and gender are related. That would be my conclusion. All right, well, let's go on to the M&Ms and see how that shook out. So if you click the little tab at the bottom, there's M&Ms. And this hopefully will go relatively quickly. I'll just walk you through this, and then you're going to do the same thing on your homework. So this is the actual data that you gave me. Remember, I collected at least the ones who actually submitted the various colors and then the different flavors. So we need the totals. So first thing you do when you do this on when you're doing this for your homework is you're going to go copy the data. Yes?
Can you go back to the last one?
Yes. Just a minute. I'll find it. Okay, what about the last one?
The crit value.
I think the problem is you got an iPad.
Yeah, I think so.
I'm just kidding.
Not really, it's terrible.
Well, yeah, for certain things. You got it now? You don't even have a
Yeah, I got it.
keyboard? I'll get you. I've got a keyboard I can give you. I'll bring it in. All right. Anything else? Other ones? All right, M&Ms. M&Ms, let's do it. So I'm going to do this relatively quickly, so try to keep up. So we got the totals that we have to compute. Here, maybe I should highlight these so you know this is the stuff that I am computing. So I'm computing the, oh, why did that not change? Oh, because I've got 2 screens. I don't know what screen I'm on. So those totals I'm about to compute, it's going to be equal to the sum of the numbers above it. There you go. And just copy that formula over to the right. There they are. So there's my totals. Maybe I'll zoom out just a bit so that you can see a little bit better. There we go. And then I have this totals here, which I suppose I should also highlight. There we go. So this is going to equal, let's see, equal the row total. So this is the sum of the numbers over here. And copy that down there. So I'll pause for a minute, but hopefully you can figure that one out. Second thing that you're going to do, and I know I'm going super quick, but you know, we only have so much time, is I copy the data. So I've made a second a copy of the data below, and I'm going to relabel that as expected and get rid of all my numbers because they're going to bother me. I guess I can highlight those as well. Now they're kind of skin color, or I don't know, what is that? Oh, that's a different yellow up there. It looks different on my screen. Looks sort of like a, well, like a white person flesh color over here. Anyway, so now we're going to do this. So remind you what this is. We're going to round because of Newton. And then we're going to do the row total times the column total. I'll get the dollar signs in a minute, divided by the grand total. And I'm rounding this to 1 digit because Newton wants me to. Let me put so hit enter, and then I'm going to go put the dollar signs in there so that you can see where they go. So the first one, the row total, I always want that to be in column G. This I always want to be in row 4, and this will always be that. So there's that. That's the worst part, is if you can get that straight, it'll be 32.9. So I'll give you a minute just in case anyone wants to come to ask. Maybe I'll pull up, while I'm doing that, I'll pull up my Newton so that we can look at Newton and be happy about it. So 32.9, if you don't get 32.9, you got a problem. April. All right, so let's see where we are. Hopefully everyone's got 32.9, and if you got your dollar signs, you can take that and copy it and paste it through here. By the way, what I do, if I want to copy and paste a formula through a grid like this, I highlight the whole grid, and then I click, or I do Control D for down, Control R for right. By the way, all of these little tips and tricks, if you take, there's a course that we have here called, I don't know, it's like Excel skills, ABT 2013, I think it is. Anyway, excellent course which teaches you how to be an Excel magician. So do that if you really are interested. If not, just try your best to keep up. So just so you know, here's what my formulas look like. There's this one. They all look similar. Now that I've got that, I'm going to compute the p-value. I know this is super quick. The test statistic and the critical value. So let's do this. So the p-value is going to equal chi-squa dot test. And then it kind of hints there, you want the actual numbers, which are the ones up in the top here, the observed. Whoops. Oh, come on. Sorry, it didn't obey me. Okay, there it is. And then you want the observed, or the expected numbers, and they have to be rounded to make Newton happy. And then, oh, that's all we need there. So let's see. Interesting. It's actually higher than I thought it would be. But let's get our test statistic. So the test statistic is going to equal chi-squa dot inv dot rt of that number, and then degrees of freedom. So let's think about degrees of freedom. I have 5 colors. 5 colors minus 1 is 4. I have 2 flavors. 2 flavors minus 1 is 1. 4 times 1 is 4. So that's the degrees of freedom. So it's the number of categories, number minus 1 times number of categories minus 1. So if the grid was bigger, you'd have a larger number. Anyway, there it is. And then finally, if we want the critical value, you could just look it up on the table, but I'll do it on here as well. This is chi-squa dot inv dot rt. And this is going to be my alpha level now in degrees of freedom. 3 minutes. So here, sadly, this is not typical when I do M&Ms, just so you know. Usually, I guess apparently the springtime M&Ms are basically the same color scheme, whereas usually you'd find that there is a difference between plain and peanut M&Ms. All right, let's just take a peek at Newton before you pack up and go here. And if you do have trouble, that's not Newton, just a minute. Here we go. This is Newton. Here, let's see, preview as a student, just so you can see what you're getting into. So I want to show you one thing about this. I think the rest of it is going to be fine. So notice that they have everything sort of worked out for you. Oh, they even have this. But to get this into Excel, here's the difficult part, is you have to highlight. This is a little annoying. Highlight the data. I guess we could highlight the totals as well. So highlight all of this. I copy. So copy. And then when you go over here to Excel, you're going to paste this in there somewhere. Like I'll just put it here, paste. And that's the first step. But then after that, the rest of this is pretty straightforward. These are the observed numbers, and they've even done the totals for you. And then they ask you about the computing the expected numbers down there. So I believe the rest should work the way that we did it here. If you just follow along the video, you can always pause the video that we just made, and hopefully it'll work for you. And we'll see you, I guess we're done. See you on Monday. I'm going to stop the recording if you want to come chat.